Hello, I'm back for a new video for MicroPython tutorial series using ESP32. In this video, we will learn how to create a web server hosted in ESP32 using MicroPython language for controlling the state of a GPIO pin. This knowledge can be used for controlling a relay, which is popular in home automation projects. For the sake of simplicity, I will only use LED for the demonstration. First, we will configure the ESP32 Wi-Fi as a station and connect it to a Wi-Fi router. The Wi-Fi router will serve as a middleman between the ESP32 web server and the client. The client could be any device with Wi-Fi capability. So without further delay, let's begin with the basics. ESP32 can be configured as a station or as access point, or both station and access point at the same time. In this tutorial, we will use the station mode only. Let's begin by importing the necessary module for the Wi-Fi, which is a network module. Import network. It is a standard module, so we don't need to manually install it. Now create a Wi-Fi object. Let's call it STA, short for station mode. And configure it as a station by calling the WLAN class from the network module. Network.wlan, and use the STA_IF constant from the network module. So the network STA_IF, which stands for station interface. Now to activate the Wi-Fi station mode, use STA.active and set its parameters to true. Hit enter. Since we configured the ESP32 Wi-Fi as a station, we need to connect it to an access point or a Wi-Fi router. Let's scan for the available Wi-Fi by calling the scan function. That is sta.scan. Give it some time and it should give the list of available Wi-Fi access point around. We can verify if the ESP32 Wi-Fi station is currently connected to an access point by calling the isConnected function, that is sta.isConnected function, which is currently it's not connected to any Wi-Fi router. Now in order to connect it to an access point, use the connect function, that is sta.connect, and provide parameters as follows: your SSID, then your password. I will not be typing my Wi-Fi credentials here for security purposes. What I would do is I will create another Python file and I will save it in the root directory of the MicroPython device. I will type here SSID is equal to your SSID. This is the name of your Wi-Fi router. Then password is equal to your password. And I will save it in the MicroPython device, and I will name it Wi-Fi_credentials.py. Hit OK. You will need to change your SSID according to the name of your Wi-Fi router or your access point and the respective password. Let me modify the Wi-Fi credentials.py according to my Wi-Fi router. Okay, I'm back. Now in order to use the Wi-Fi credentials file that we recently created, we need to import it. So that is import Wi-Fi underscore credentials. No need to put the extension. Just leave it as like this. Hit enter. Now we can continue connecting to the Wi-Fi router by calling the connect function, that is sta.connect, and provide the SSID and the password as parameters. To access the Wi-Fi credentials, we will just need to Wi-Fi underscore credentials dot SSID, comma, Wi-Fi credentials dot password for the password, and close it. Hit enter. Now we can check if we successfully connected to the access point by calling the isConnected function. sta.isConnected. Open and close. Hit enter. Now we are connected. We can get the IP address of the ESP32 by calling the ifconfig function, that is sta.ifconfig. Open and close. Hit enter. The ESP32 is now configured as a station and connected to a Wi-Fi router. We will use a WebSocket to communicate with the clients viewing the web page hosted by ESP32. Now, to make it clear and easy for you to understand, let's see the demonstration first. Then after that, we will try to walk through the source code later on. I have here a source code prepared. Let me run it and give it some time to give us its IP address. Okay, this is the IP address we need. And let me open and let me type it 192.168.0.100. That is the IP address here. Hit enter. And it should give us the web server for controlling the LED. Now my computer will serve as a WebSocket client. You may use any web browser of your choice. I will just use a Brave browser. Another thing is to make sure that the ESP32 and the client is on the same Wi-Fi router connection, or else this setup will not work. In this page, we can control the state of the LED by clicking the LED on. And as you can see, the onboard LED turns on. Or turn it off by clicking the LED off button. Of course, if you decided to use it for the actual operation, like for home automation, you may use a relay instead of LED. And as you may notice, the status display is also updated accordingly. Now LED is now on, LED is now off. Okay, now let's try to dissect the code briefly. In the first part, we created a pin object named LED, which is connected to gpio2 and set the pin direction as an output. And we initialize it to LED off. Next is the configuration of ESP32 to function as Wi-Fi station, by which we already learned recently. So we begin by importing the network, then we import the Wi-Fi credentials for connecting to Wi-Fi router. Then we create a wireless local area network or WLAN and configure it as a station using sta_if. Then this if statement makes sure that the station is not currently connected to any Wi-Fi access point. Inside it, it prints a debug message. Then it activates the station. Then it connects to the Wi-Fi router. And wait for it until it's successfully connected to the Wi-Fi router. And lastly, it prints the IP address. Next is the configuration of the socket connection. It begins by importing the socket, which is a standard module available inside the MicroPython firmware. Then we create socket object named S by calling the socket class and set it as TCP over IP configuration. AFINet means use Internet Protocol version 4 addresses, while SockStream is to use a TCP socket. Next is the s.bind, which specifies that the socket is reachable by any IP address through port 80. Next is s.listen, which sets the maximum number of socket connection it can accommodate. In this case, is 5 socket clients. Next, we created a function that will be called when a client connected to the web server. It basically contains a simple HTML code of the web page of the web server. And as you can see, don't worry, I will provide the source code in the blog post I will be posting later on. And for updating the LED state, we have here an if statement which will read the current state of the LED pin and update it accordingly. You may notice that in order to cut in chunks the HTML code, we are using 3 double quotation marks. This is to be able to append a MicroPython code which is a non-HTML code, such as this LED state. So we basically starts here with 3 double quotes. We end here, we append the non-HTML code, then append again the HTML code until here. Then the function exits by returning the assembled web page. And lastly is the main loop. In the main loop, we accept a client socket connection. Then we assign a 1024 bytes of data buffer for the client data. Then to check if what button is pressed, we are checking the URL requested by the client here. So we basically checking if the URL have this string, which is this one. If this one is 1, we can turn on the LED. As you can see, the LED on board is turned on. If the URL contains LED is equal to 1, it means that the socket client requests to turn on the LED, while LED equal to 0 means turn it off. After the LED is controlled by turning on or off, the web page is updated by sending it to the client as a reply. So here, we just updated if LED on, which is if we check this one and it finds this string, it will return a number here, which is 6. So to see that, the 6 is, let me turn on, content, get, here. From here, that is 0, 1, 2, 3, 4, 5. Then this is the 6, which is here. So if LED is equal 1, then LED on will become 6, else others. So if LED on is equal to 6, it turns on the LED, while if LED off is equal to 6, it turns off the LED. After that one, it calls the web page function, which replies with this one, and it sends the web page back to the client. Before it exits, it closes the socket connection. So that's all for now. I have a similar video posted a few months ago for ESP32 web server, both for station mode and access point mode, using Arduino environment. Be sure to check it out. I will post the link below in the video description. If you have any question regarding this tutorial, you may write your inquiry in the comment box provided. And if you enjoyed this video, please give me thumbs up by clicking the like button and share this to your friends so that it can reach more people who might benefit from this. And if you are not yet subscribed, please do subscribe now. You might also like to visit my blog post at tech2tinker.blogspot.com for more details and references such as circuit diagram and source code. Thank you and have a good days ahead. I hope to see you in the next video. Bye-bye!